I'm Rob Grant. I'm the industrial designer for the CSeries. And I just wanted to say, I'm surprised how much we put our attention to the backs of the seats when outside is the real show. We're, 30,000 feet in the air and 800 kilometers per hour. So one day I think outside will be where we'll focus our attention, just like your concept there. But anyway, that's not why we're here. So I'd just like to say the CSeries is Bombardier's largest single-aisle commercial airliner. And it's a clean sheet design, so that gave us a unique opportunity to consider accessibility from the very beginning, which sometimes it ends up being more of an afterthought or a retrofit. So first I'd like to talk a little bit about our design team philosophy. So a number of key assumptions guided our design effort. And the first being air travel needs to be accessible to all levels of mobility. And this is a very simple enough statement, but a very complex task to achieve. But it's not impossible. Oops, I'm a newbie here, I'm sorry. Okay, the second key assumption that we held was the view that reduced mobility is not necessarily an abnormality, but is a normal part of the human range of human mobility. When we start to view things as abnormal, they may be easily dismissed or be seen as a rare occurrence, which isn't quite the case. In fact, people are living longer with mobility impairments due to medical science innovations. The world's population, as we spoke of, is aging, leading to larger percentages of elderly in our public spaces. And as well, there are increasing numbers of people with mobility issues who choose to travel nowadays. I apologize for my notes. I try to fit too much in my presentations, so I rely heavily on them. The third point is that at some point in our lives, I think each of us will experience some form of impairment, mobility impairment. So in childhood, we have strength and size limitations. So you've always seen a small child push a chair up to the counter to get the cookies on the countertop. Even our high-performance athletes at their peak mobility can have a sports-related injury and become temporarily or permanently impacted. And in pregnancy, of course, we have mobility issues that are 9 months in duration or about there, but they don't last forever. And of course, with the popularity of our cell phones, we can be staring at our phone and walk into the street carelessly, and that can have very different outcomes as well in terms of mobility. Old age, we can diminish our physical capabilities as we begin to lose strength, coordination, and endurance, although this happens at varying rates depending on who we're talking about. And finally, disease can have a profound effect on our ability to move about our environment. And here's the picture I meant to show just now. So inclusive design is the framework that best represents our design philosophy. And inclusive design, basically the terminology is, the goal of inclusive design is to accommodate as many people as reasonably possible without the need for specialized design. So as is reasonable, that is with due consideration given to the many constraints and parameters in the business environment. And that's a unique thing about inclusive design as a theory or a framework. So the technology, what solutions are or aren't available? Safety regulations and certification requirements, can they be met? Manufacturability. Weight is king in aviation, so lower weight means fuel savings. It means better flight range. And the lower the weight of the aircraft, the greater amount of revenue generating passengers and cargo that can be accommodated. So this is very important for the operators. And finally, cost. Can the cost be justified and still support the business case? These are serious concerns that must be addressed if design is to be accepted. and especially within this extremely conservative industry. So the next term, the need for specialized design. So if accessibility is not built in from the beginning as a type spec or base model, then it becomes a specialized design. Essentially, what can be a costly option to be purchased. So now, in effect, the airline is being put in this position of, do they increase their cost to pay for accessible design, or do they keep costs low and exclude those with mobility impairments? I mean, that's a black and white scenario, but this is typically what we see. So if accessibility was integrated into the type spec aircraft offering, then this is no longer an issue. But how do you do this? It's not an easy thing to do. One way is with a clean sheet aircraft, which doesn't happen that often. And in this case, design for accessibility would become a non-recurring cost that is included in the initial development spending. Another way is accessible features can be used throughout the aircraft, bringing part commonality benefits, which are additional savings in time, manpower, and cost. And finally, new design should not negatively impact use by other members of the traveling public. So this is a very basic statement. What sense does it make to improve things for one group and in turn increase the difficulty for another? It's counterproductive and very costly. Oops, I'm sorry, I'm catching up. And now I'm going backwards. So I'd like to provide a quick overview of our PRM lavatory study. Lavatory D, as you see in the picture, is in the aft of the aircraft on the right-hand side. It's a similar footprint found on other popular aircraft in service today. Two organizations were key to the success of our PRM study, and they are CARUL and the Quebec Adapted Sailing Association. So participants in this study ranged from seniors with full mobility to persons with quadriplegia. And blind participants were also included in the study to assess the intuitiveness of the design and the placement of certain items. So end user participant groups are essential for offering real-time input as well as valuable past experience that, as Stefan said, the engineers really can't estimate that. It has to be from the people that experience it. So part one of our study is a simulation exercise, or was a simulation exercise. And the mock-up was based on the available space provided by the program. So this is typically what you'd find on an Airbus product in the back on the right-hand side. So it's a similar size. The standard dimensions came from various sources, one being architectural building codes and current literature on the subject of accommodation. Participants were asked to enter the lavatory independently or with assistance if they required, and they were asked to determine if the door was able to close fully once inside. So privacy is a big issue, and I'll talk later about curtains and how they don't quite do the job for privacy and dignity. I'm just going to take a quick sip of water. So next they were asked to transfer to the toilet and back again from the aisle chair, if able to do so. And we found that not everybody was able to do so. It really required a lot of upper body strength. So that really limited the use by a number of people. So we had to take care to make sure we incorporated that into our study. A series of reach scenarios were simulated from the the aisle chair and the toilet locations to ensure that all the amenities were within reach. Other inquiries that we asked about were, could the person use the mirror? Was the mirror low enough? What were the impressions of a window in the lavatory to increase the space, the perception of space, I guess? Where did they prefer to place their hands to support their weight? And were they able to pick up a dropped item, which typically can happen, and you don't want to have to ask for help every time you need to pick up something. And I'm so sorry. I'm really new at this. Okay, so the second part of our study was a qualitative interview, and it was meant to evaluate the simulation. So first, people were asked, what were the positives, the negatives? Was something missing? Was something positioned improperly for their typical ability, or sorry, their specific ability? And designers and engineers really can only go so far in an educated guess. Pardon me again. They were also asked about past travel experiences. So what do you do during a flight if you need to use the washroom? And do you not go at all sometimes if you don't want to go through the ordeal? As well, what do you do if you need to call the flight attendant and you can't reach the call button? If you need to retrieve an item from the luggage bin, if you don't have a travel partner with you. So the purpose was to identify the less tangible issues influencing the flight experience for people with mobility impairments. And the two main ones were privacy and dignity. So external contributors were also very important to us. Past barriers to access were asked about. What time in their lives did they receive their impairment? So was it from birth? Was it an accident later in life? Or was it due to the natural course of time? So this information was put to good use and carried great weight with the engineering team, which was really the first time we spent a lot of the program's time looking at this. The first aircraft that Bombardier actually did this with. So let's look at some of the features of the lavatory design a little, excuse me, in a little more detail. So the concept phase, design development begins with a series of high-level concepts. So taking into account prior assumptions and findings, current industry standards, and design intent. So the concept phase occurs and is refined throughout the entire duration of the design process. It doesn't just happen at the beginning. So lavatory D is what we call this lavatory, this specific lavatory. Some of the features, so the clamshell door, as you can see on the right-hand side of the picture, it is an extra panel opened by the cabin crew to provide an extra wide doorway for wheelchair access. And the important part is to provide that access at an angle that allows a safe transfer. As well, the extra space is wide enough for a bariatric passenger who might need a little extra room. Full ingress is possible with this occupant. With an occupant and the aisle chair inside with the door closed. And that's a 95th percentile male that we used to determine that. So it is very important for privacy reasons to have the door closed, obviously. In the past, curtains have been used to give a sense of privacy aboard aircraft, which is now considered insufficient. Standalone functionality. So PRM use of this lavatory does not remove an additional adjacent lavatory from service. So that is, two lavatories are not combined to form one single PRM lavatory. So and that goes back to not reducing the usability of the cabin for anyone else. So you don't want to remove a lavatory if there's already a lineup in the aisle typically. Space below the countertop. So systems have been rerouted to clear space under the countertop for passengers' legs while on an aisle chair and to enable a safe transfer. And more often than not, the face of the countertop in an aircraft lavatory will extend right to the floor and leave little, if any, room for passengers' legs or for a transfer. A dedicated assist handle. So this is something that we've seen with Boeing as well on the 787. So this assist handle is dedicated to provide a lower pivot point while transferring from the aisle chair to the toilet. And what we found was this was good for some people, but not all people. And it's a real challenge to find common locations where you can accommodate the majority of people. But the handle rotates out of the way in what is affectionately known as the P zone, in an attempt to keep it clean. Excuse me. So the next step is to have the handle recessed completely within the shroud to keep it sterile when not in use. And that's really the only way to keep it clean. And finally, reach to amenities, sorry. They have been optimized for this lavatory. Essential emergency items can be accessed from the toilet and the aisle chair. And while most other conveniences are accessed after the transfer back to the aisle chair. So I'd just like to say I don't see these recent lavatory innovations as the final solution by any means. They're a good start, and I think we have a lot of work to do in aircraft to accommodate, as my colleague said, the large number of people who will be bariatric, who will be seniors, who will be injured with a cast. You know, there will be a big challenge coming our way as an industry. So the emphasis on accessibility during the CSeries program gives me a lot of a lot of optimism for the future of air travel and passenger mobility. So what's next? I like to end things with, much like Stefan did, with a little bit of talk about the future. And I personally love to sit at the window seat, so I can't see why someone in a wheelchair wouldn't also like to sit at a window seat. So this is something that I'd like to take on, is find a way that we can do a safe transfer to a window seat and then be able to get out of that seat in a hurry in an emergency situation. So this is a challenge. I've also worked for a major airline for 12 years, so I've lifted a few people from an aisle chair into their seat, and it's challenging both for the person in the chair and for the people trying to move them. So maybe a leaning or twisting aisle seat, something that mechanically moves into the aisle or twists and accepts a better transfer. These are very high-level concepts, and they'll need a lot more of realistic investigation and engineering help. But some of the crazy ideas lead to some of the best design, is what I find. Okay, so what do we have here? Additional investigations into dependent transfers. In single aisle, it's very difficult to have a dependent transfer, especially within a standalone lavatory, and this is something I think we should look at. More information on the care of bariatric passengers is also required, and I think this is really where the airline industry, or sorry, the aircraft industry is falling short. We have a lot of larger people, and the population, although it's growing older, is also growing larger, and we have to be ready for this. And maybe the most fun is the smart cabins idea. So you're at a tropical resort, and you might have a wristband on, and maybe this wristband is your boarding pass, and maybe it has a little chip in it. So when you enter the seat envelope, maybe the seat knows that you have an impairment in your leg. Maybe it adjusts to somehow accommodate that. Or maybe you move into the lavatory, and the lavatory knows that you might need extra help in this other way, so it somehow morphs. That sounds like science fiction, but it somehow adapts to you. And I think that's really the key, is environments that adapt to people, not people having to adapt to poor design. So the final thing I'd like to say is that gatherings like this will make future progress possible. So I'm really happy to be here. So thank you very much.
Thank you very much, Robert. Any question? Time for one question? Okay, it's your turn.
Will there be any movements increasing the size of the transfer chair?
That's a really tough question, and aircraft are working on making their aisles bigger. I mean, when you increase one dimension, you have to decrease another. So if you increase the aisle, you have to reduce the seats or the armrest size. It's got to give somewhere. So my short answer is As wide as the aisle is, the aisle chair will be wider as well. And I have found a really good aisle chair that's wider, it's shorter, and it's lighter. So this is something that we have been pushing towards our customers.
Well, thank you very much. I'd like to thank